is 4. B divided by 2, 25 divided by 2 is 12. Right? 4,12 plus 2. That's where I got this from. Now I have to evaluate mystery on 4,12. Right? So if it's 12, 0, no. Is 12 even? Yes. So I will return mystery on this guy plus this guy is 8, comma 6, right? Yeah, B divided by 2. And then this we call again M, since this guy is still even, right?
What about
16,
2?
Comma.
What about plus 2? You don't have to do that?
No, because here you don't have plus 2, look. When it's even, you don't have plus 2.
Oh, okay.
Got it? Now, you're passing again 6. 6 is even too, right? So you're going to pass this guy plus itself in the half plate, right? Now you're passing this guy. This guy is not 0 yet. And it's still what? Add. So now you're going to return M of 32, 3 divided by 2 is 1, right? Plus 2, right? No, plus 8, which is 16, right? Got it? Yes? And then? Sorry? I went to the second one. Okay, now M of 1 is not 0 yet, but it's even. So it's add, right? So 64, 1 divided by 2 is 0. Plus 32, right? Now, is B 0? Yes, stopping condition. I would return 0. Got it? So now I can plug it in here. This result is 32, right? 0 plus 32, the result is 32, right? I can plug it in here. 32 here plus 16 is 48, right? Correct? I can plug it in here. It's still 48 because here it was just a simple call to this one. Here this was a simple call to this one, so 48 still. I will plug in here 48 plus 2, 50. That's the answer. That could come in your exam. It will give you something like this. You're not programming, you're just evaluating. Seriously, guys, without exaggerating, is this out of the air? Is this a Mars exercise?
Yes or no?
That is Princeton. Okay, and I can pick any top school like that and pick exercise and we can solve it. I do that at the Miami all the time when I was one. You my student there. I do that all the time. Why? Not to put Princeton down. Princeton is a great school. Just to put you up, guys. For you to realize that you are smart and that the knowledge that we get here is the same everywhere. This problem is from Princeton, top school. If I use here, Princeton is here. I know. But the brains that you've got can make you solve any exercise. I learned all of this in Spanish, like I told you. The same thing. Yes, man.
The last time we did it from MIT.
Last time we did it from MIT, right? It's the same thing, guys. It's the same thing. Okay? It's the same exact thing. Here are more exercises. Some of them try to become mathematical, and that doesn't really make it hard. Just different. Here is a similar exercise, you see? Similar exercise. They call it function. Okay, you put here system operating 9 instead of STD out. And you can keep playing it out. Here you have McCarthy, another exercise, and see what happens. So you see what the kind of things we can do, right? Just evaluate, right? And this is not hard. This is not hard at all. Here another example of mixing, another kind of thing that you are doing. In this case, for example, we're going to get a Newton over, or a Newton loop. That means that we're never going to reach this stopping condition. That's what they are saying. Clear? Okay, so let's see if I can look for something different. Let me think of one of my own. I'm going to do my T. See if we can find my T. And guys, it's even cool. So this is tree recursion. We're having that trees yet. It doesn't really matter if it's in a different language. It doesn't really matter if it's in a different language. Just solve it. Look at this recursion. Very stupid, right? There's 4 lines of code. And this is even stupid because you don't need the else. How many of you played the raspadito? Come on. All of you played the raspadito, right? A little game where you scratch numbers and make powerball. Okay, what if I ask you to simulate the game of the raspadito? Okay? Simulate a scratch game where you scratch the numbers and see if they match, okay? Speak Spanish, you guys don't pretend you don't, right? Anyway, I want you to pretend that you're playing the game, simulate the game, and I want you to create a method that returns how many times you had to play until you finally got a match. A full match. Okay?
How do you do it?
Do that. That's your problem. Okay. Maybe something even more complex. Let's say the lotto. You have 50, 63 numbers, right? Or whatever numbers you have, right? And randomly, supposedly randomly, because it's computerized, nothing is random when it's computerized, but randomly, 6 numbers are going to be generated, right? And you pick 6 numbers and you want to see how they match, right? So how do we simulate that? How many times you have to play until you match? So we can play with something even smaller, okay? I'll play with a smaller set of the problem. I'll try to simplify the problem to make it recursive, okay? Let's simplify the problem. Let's say I'm going to generate two random numbers, okay? One random number that simulates the computer generating a random number for the lottery, meaning the company. Florida Lottery generating the random number, one random number, just one, from 1 to 10. Okay? Got it? And now create another random number, generate another random number that simulates the user picking a random number, which is any of you, when you select a number, it's random because I don't know what you're going to select. I say Darlene, pick a number, and she picks a number, it's random because I don't know what she's going to pick. Same with any of you, right? And what I'm going to do is every iteration of every recursive call, I will generate 2 random numbers. If they match, I will return 1, meaning that you had 1 attempt to get it, right? But if they don't match, I will call the recursion and increment the count now, because now that means that you have to try again. Got it? Is that clear?
Yeah.
That simulates kind of the game, but in a very, very simplified way, right? So this method, this recursive method, is going to tell you how many times you have to play until you finally have a match. Okay?
Only 2 numbers, 1 and 1.
2 numbers, yes, just 1 and 1. One simulates your play, the other one simulates the computer generating a random number. Okay?
The number can be any number.
I'm going to pick from 1 to 10 to make it simple. If you're to play the lotto, should be one from 1 to 60 something, which is crazy. That's why people waste their money. But anyway. Okay? Int n equals n times you play. That's going to be the method, okay? You play these many times.
Plus that.
Yes, thank you very much. Pay a lot of attention to this exercise, guys. Should have said it louder, man, so everybody hears. So, you enrolled in my class? You are, right? You're officially enrolled in my class, right? Yes. You are not the one that is not, right? Surely here, right? So, okay, let's play with this. I'm going to say machine, to simulate a machine generating a random number. If I want from 1 to 10, how do I do that? If I put 10 here, it's going to generate from 0 to 9.
10 plus 1.
Good. This will make from 0 to 9, since I'm adding plus 1 to any of that result, now it's going to go from 1 to 10. Got it? Now, I'm going to generate an int user pick. This is going to simulate the user pick. 10 plus 1, right? Now, if the machine is equal to the user pick, let me call it machine pick, okay, to make it more descriptive. If the machine is equal to the user pick, that means that you just played 1 time only. one time only, and you got lucky, right? Else, that means that you have to play again, right? Pick another number and have the machine generate another number. Like you're playing the Lotto next week, right? Again, right? So that means that you play at least once, right? Plus the next play that you have to make, right? Got it? Is that clear? Yes.
Yeah, I'm just saying, don't you have to pass something to that method?
No, because everything is generated inside here.
But what you pick?
What you pick, you're picking here randomly.
Oh, it's just picking for you, right.
I'm simulating the pick in the machine. That's one.
Okay.
A different method could be that you receive the user picks just one number and you keep trying until you match, right? This is different. Every time I'm picking one, then the machine picks. Like each time, guys, hold on one second. This simulates each time you play the Lotto. Okay, you go to the gas station, you buy your Lotto, okay? Then it's random, right? The numbers you choose is random. The numbers the computer generates are random, right? And you don't win, you wasted your dollar, right? Next week you play again. Your picks don't necessarily have to be the same as before, right? It's another random set of numbers, right? And the computer will generate another random set of numbers, right? So that means that you had at least 2 tries, right? When you get to 150 something years old, you win, right? You're there already. Yes.
No, I was gonna say, the purpose of this is just to see how many times they can go before
You win.
Got it.
Okay?
And then recursively keeps running, returning to one.
Correct.
Finally get it, when you all the ones back.
Okay, for this number was already, this area was already used for a time. So you have to keep playing. You played 2 times. You were lucky. You may play again. Maybe I will have to play more times. Ah, 25 times. Now, I played the Lotto. How many numbers does the Lotto have? 63? I think 63, right? Sorry? 67? I don't know.
I can play the Powerball.
Okay, let's say, Powerball. Let's say Powerball. 58. Good, good.
I play it every.
Now, that's to get one number. You have to get like 5 numbers there,
Plus
right?
the Powerball.
Plus the Powerball, so 6 numbers in total, right?
User pick.
Sorry?
User pick.
Oh, my bad. Yeah.
So if you win, you wouldn't see me ever again. Right?
So, check it out. 33, you were like, okay, crazy.
Yeah.
Now, imagine, now you have to combine 6 numbers. So the number of times, the probability is even harder. Right?
What? Those are little Powerball.
The probability is harder when you have to combine more numbers.
Oh.
You were just to hit one number, that's it.
And it's fine.
No. I remember there was a time my country's lotteries were different. So lotteries had 36, but now it became like here. But at one point, lotteries were 36 numbers only. Okay? 36 numbers. So smaller numbers, more probability, right? And the price keeps growing and growing every week, right? I remember it got to a point where it was so much money that if you were rich enough to buy all possible combinations, I made the math. So for all possible combinations, right? And you would buy all those tickets with all those possible numbers, you were going to win for sure, right? And still you made profit. But nobody thought of that, because if somebody would have thought of that, that would have been a great business. It's a win business, for sure. Play all numbers, you might waste maybe $2 million. But if the price is $3 million, you're making $1 million profit, right? But it's more than 2 million. It's more than 2 million. Trust me, it's more than 2 million. For the Powerball, for the Lotto, I think it's like 63 million.
You have to go play somewhere else, go like a gas station with $2 million.
Maybe there's a restriction on how many numbers you can buy. I don't know. But also there is a problem, right? When you win the lottery, they pay you in cards, and they tax screws you up, and then out of the $5 million, you get $500.
I want it all. You take your 50%, I'll take more than 50%. I'll take it up front. Yeah.
You can take it up front, right?
Yeah, but then they take off almost half.
It's like half of it, right?
Yeah, I'll get half.
No, you get 60%, I think it is.
You carry in your pocket there?
Yeah.
All right. $30 million? Yeah, good.
Yeah. Just 10% of that is a lot of money sometimes, right?
You only carry 60%.
One more example. Okay, one thing that you can practice is calculate the sum of an array. Okay? If essentially the sum of all elements recursively. Okay? We did the power last class, right? The power, right? Let's see what else we can do. Sorry?
You said easy.
Exam?
No, I'm saying, like, you want to make an easy example now?
Something like this. This example is different because in this example, like he was telling me, there is no parameters, right? And still you can have recursion without parameters and you can steal the stuff,
Try
right?
to give us something like Fibonacci or power.
I see people sometimes I don't like making too much mathematical problem because people sometimes complain. They say, no, we don't like math for including IT, we don't want to put anything math. I try to put more logical things.
Fibonacci, I know. I don't know power.
Basically,
What do you mean you
Answers the
memorize?
harder problems on the test.
Adding shorter. What?
Why would they do it?
Fibonacci's like, well,
No, I know that.
I remember the method.
Oh,
Recursive.
put one of the last.
That was like start.
Yeah.
So here, for example, guys, you have this example in my ask. It's very simple, similar to the one we did before. This is a nice exercise, for example, you can practice. So you get a string, like A, B, C, D, and a number. Okay, so the recursion receives a string and a number. And you have to return, say, an array of strings or just print out all the possible substrings that you can generate of size 3. Got it? Recursion. That's easy. The very common division. This is a nice drawing. It is very, very easy. It's the algorithm. Guys, if you start thinking things are too hard, you need more Fibonacci.
I think a good one is the prime number.
Determine how many prime numbers you have in a range.
Or you just determine recursively if the number is prime.
That's an easy one. If you have a number and you want to determine if a number is prime, what's the condition for a number to be prime? It divides
By
itself,
itself.
right? It's a bounding itself, right? So what you do is you start testing from, if you want to make it a lane grid, you start going from all numbers, 2, 3, 4, 5, until you reach that number, right? And keep a counter, right? Of how many numbers have divided. If the counter is 0, then that means the number is a prime number, right?
Or you
Or
can
you
check if
even
it's
check-
divisible by 2.
If the number
You
you're
can divide the
dividing
range
it
you
by,
have. That's if you want to optimize it. If you want to make it simple, that's what I'm saying. Yeah, I know you can optimize it and go up to half all the way. But if you want to make it like very stupidly, you can have something like this. Check prime, for example. Check prime. Okay? Return a boolean, true or false. You receive a number n in a counter, say int c counter. This counter initially 2, for example. Once the counter reaches the number, that's your stopping condition. If the counter reaches the number, then you return false. The number is a prime. You have to reach there to find a division. If you can divide before that, then it's not a prime number. You want the solution?
Seems like a hash.
If c equal n, return false. Else if n percentage c is equal to 0, then return true. Else just call whatever, right? Else we call check prime on n comma c++. That's it. I gave you the solution already. Okay, guys? Here's the solution. Good example. Good example.
Can you check if it's divisible by 2 and have the remainder?
What about, what about 9? It's divisible by what? But it's not. It's divisible by 3.
Yeah.
This is a very, guys, this is a very simple exercise. So if you want more, you can go to the page here. You can do that the arrays. Okay? You can simulate a flip of a coin. How many times you have to flip a coin and you get tails, for example? You understand what I'm saying? Yes? But if you don't practice, it will be hard. See you next class with your exam, okay?
So next